Have you ever looked at a puddle after a rainstorm and wondered where it goes? One minute it's there, a perfect little mirror for the sky, and the next it's gone. It didn't just vanish into thin air. Or did it? Well, in a way it did. All the water on our planet. In our oceans, our rivers, our bodies. And yes, even in those puddles, is on a constant, incredible journey. This journey is called the water cycle. It's a huge, planet-sized system that is always moving, always changing, and always working to keep our world alive and well. It's a fundamental process of science, and understanding it helps us understand our weather, our climate, and even our own lives. The water cycle isn't just some far-off scientific concept. It's happening all around you, right now. It's why we have clouds in the sky, why rain falls to water the plants, and why we have fresh water to drink. Think of it like a giant recycling program for Earth's most precious resource. Water gets used. It moves from one place to another. It gets cleaned up, and then it's delivered right back to where it's needed. Here's a mind-blowing fact to get us started. The water you drank today could be the very same water that a dinosaur splashed in millions of years ago. That's right, the total amount of water on Earth has remained pretty much the same for billions of years. It just gets moved around and recycled over and over again through the water cycle. This means every drop has a history, a story of where it's been. It could have been frozen in an Antarctic ice sheet for 1,000 years, or it might have just evaporated from the Pacific Ocean last week, before falling as rain in your neighborhood. It's the ultimate world traveler. This constant recycling is incredibly important for life. The water cycle isn't just about moving water from point A to point B. It's also Earth's natural purification system. The water cycle is driven by a very powerful and very free source of energy: the sun. The sun's heat provides the energy needed to kickstart the whole process. It warms the surface of the earth, causing water in oceans, water in lakes, and even the moisture in the soil to heat up and change. This solar energy is what powers the lift that gets water into the atmosphere, and gravity is what brings it back down. It's a beautifully balanced system, a dance between the sun's energy and the earth's gravity, with water as the star performer. As we mentioned, we can understand this grand performance by focusing on its three main acts: evaporation, condensation, precipitation. These are the core processes that define the water cycle. Evaporation is the upward movement, condensation is the cloud-forming middle act, and precipitation is the downward return. First up is evaporation. This is the part of the cycle where water goes from being a liquid to a gas. We call this invisible gas water vapor. The main ingredient needed for evaporation is heat. And where does Earth get a whole lot of heat? From the sun, of course. The sun shines down on our planet, warming up the surfaces of oceans, lakes, rivers, puddles on the sidewalk. As the water absorbs this heat energy, its tiny molecules start to get excited and bounce around faster and faster. Eventually they get so much energy that they break free from the liquid and float up into the air as water vapor. You've seen evaporation happen in your own life, even if you didn't call it by its scientific name. Have you ever left a wet towel out in the sun to dry? After a while, the towel is no longer damp. The water didn't just soak into the ground, it evaporated into the air. The same thing happens when your mom or dad boils a pot of water on the stove. You can see the steam rising from the pot, right? That steam is just a visible form of water vapor. But it's not just big bodies of water that contribute to evaporation. Plants play a huge role too, through a process called transpiration. Think of it as plants breathing out water. Plants draw water up from the soil through their roots, use it for their life processes, and then release water vapor into the atmosphere through tiny pores on their leaves. A single large oak tree can transpire over 150,000 liters, about 40,000 gallons of water in a single year. When you combine all the evaporation from oceans and all the transpiration from plants, you get a massive amount of water being pumped into the atmosphere every single second. So evaporation is the invisible, silent lifter of the water cycle. About 71% of our planet's surface is covered by oceans. That's a massive area just waiting to be heated by the sun. We're talking about trillions upon trillions of liters. That's why you often feel that sticky, humid air in tropical places. The air is full of water vapor that has evaporated from the warm ocean. Evaporation is also the reason why clothes dry faster on a hot, windy day. The heat from the sun provides the energy for the water molecules to escape the fabric. The wind helps by blowing away the newly formed water vapor, making room for more water to evaporate. Conversely, on a cool, calm, and humid day, Your clothes might take forever to dry. Cool, calm, humid. There's less heat energy available, and the air is already saturated with water vapor, so the evaporation process slows way down. This process has a huge impact on our daily weather. Areas with lots of evaporation, like those near large bodies of water, tend to have more moisture in the air. This moisture is the fuel for future rain and storms. Meteorologists, the scientists who study and predict weather, pay very close attention to evaporation rates. So, that disappearing puddle in your driveway is actually a tiny piece of a puzzle that helps predict tomorrow's weather forecast. When they irrigate their fields, they know some water will be lost to the atmosphere, especially on hot days. That's why drip irrigation delivers water directly to the base of the plant. Once all that invisible water vapor has been lifted into the atmosphere by evaporation, it can't just stay there as a gas forever. The next act in our water cycle story is condensation. This is the process where water vapor cools down and changes back into a liquid. As the warm, moist air rises higher into the sky, it begins to cool down. You might have noticed that it gets colder if you climb a tall mountain or fly in an airplane. This cooling is the trigger for condensation. As the water vapor cools, its molecules slow down and start to clump together. But they need a little something to clump onto. They can't just form a droplet out of thin air. Instead, they gather on tiny microscopic particles floating in the atmosphere. These particles can be specks of dust, pollen, salt from the ocean spray, pollutants from factories and cars. These are called condensation nuclei. As more vapor condenses onto these particles, they form minuscule water droplets or ice crystals. When billions gather together, they become visible as a cloud. There are many different types of clouds: big, fluffy cumulus and thin, wispy cirrus high up in the sky. They are so small and light that the upward drafts of air can keep them floating. You can create your own little cloud in a bottle to see condensation in action. Take a clear plastic bottle, add a little warm water, light a match, blow it out and drop it inside. Seal the lid. The smoke from the match provides the condensation nuclei. Squeeze. Pressure and temperature rise. Release. The air cools, and a tiny cloud forms inside. It's a great way to visualize how cooling the air causes water vapor to become visible droplets, in miniature. Section 6. Seeing condensation all around us. You don't have to look up at the sky to see condensation. On a hot, humid summer day, have you ever taken a cold can of soda or a glass of iced tea outside? Within minutes, the outside of the container gets covered in little drops of water. The cold surface of the can cooled the warm, moist air right next to it, turning invisible vapor into droplets. That's dew. As air near the cool ground reaches its dew point, moisture condenses onto surfaces. Section 7, Step 3, Precipitation, when the sky delivers. We've followed water up into the atmosphere and watched it form clouds. Now the grand finale, precipitation. Water falls from clouds back to Earth. It's the delivery system bringing fresh water to land. Precipitation comes in several forms and depends mostly on air temperature. Inside a cloud, tiny droplets bump and combine, coalescence. Droplets merge, grow heavier, and fall as raindrops. Below freezing, 0 degrees Celsius, 32 Fahrenheit, vapor forms ice crystals. Crystals grow by sticking together. They get heavy and fall. Sleet starts as snow, melts in a warm layer, then refreezes into ice pellets. Hail forms in powerful thunderstorms. Pellets tossed up and down, collecting layers until they plummet. No matter its form, rain, snow, sleet, or hail, precipitation completes the cycle and replenishes Earth's fresh water. Section 8. The full circle. How the cycle shapes our world. Now let's put it all together and see the water cycle as the complete, continuous loop that it is. The sun's energy heats the Earth's surface, evaporation from oceans, lakes, rivers, transpiration from plants. Invisible water vapor rises into the atmosphere. As it rises, it cools down, it condenses onto tiny dust particles. Those particles form clouds. Inside, droplets and ice crystals combine and grow. When they become too heavy, they fall back to Earth as rain, snow, sleet, or hail. The cycle is complete and starts again. The circulation of water moves more than H2O. Evaporation absorbs energy, causing cooling. That's why sweating cools you. Condensation releases stored energy back into the atmosphere as heat. That energy movement drives weather systems. It helps create winds and powers massive storms like hurricanes, fueled by heat released from condensing water vapor over warm oceans. Rain and snow fill reservoirs and recharge aquifers, providing water we drink, cook with, and use for sanitation. Farmers rely on predictable rainfall to grow food. Droughts, long periods with little or no precipitation, can devastate agriculture. Droughts lead to crop failures. Droughts cause food shortages. Too much precipitation in a short time can cause floods. Floods can damage homes and infrastructure and harm ecosystems. City planners and engineers design our communities with the water cycle in mind. They build storm drains and sewer systems to manage runoff, and dams and reservoirs to store wet season water for dry seasons. Understanding how water evaporates, where it falls, and how it travels across the land is fundamental to sustainable, resilient cities and societies. The water cycle isn't just a science topic, it's a daily reality we manage. Section 9. Our place in the cycle, a call to wonder. So, there you have it, evaporation, condensation, and precipitation. 3 simple steps that describe one of the most powerful and essential processes on our planet. From the sun's heat lifting water into the sky to gravity, pulling it back down, the water cycle is a perfect example of nature's ingenuity. It's a system that cleans, moves, and renews our most vital resource, keeping plants, animals, and all of us alive. Because we depend on this cycle so completely, we have a responsibility to take care of it. Conserve water, turn off the faucet while brushing, take shorter showers, fix leaky taps. Keep water clean, dispose of waste properly, and be mindful of what goes down our drains. The water cycle is a beautiful demonstration of how everything is connected. Science is all around you.